lane. Here you have to neglect the child mother lane because you want to find out the other band which is coming from which male. That male is a father. Does that make sense? To make your work easy, work on these problem set. I have told you what you got to do. This is already matched, so you got to neglect this lane and see where is the other band coming from. That is belongs to father because a child has one band from mother, one band from father. Same for crime and sample and crime scene and victim. You have to neglect crime scene and victim lanes. We have also done the, please do these questions. We have also done similar question in interactive session. Again, why 4 is the DNA of father? Because at least one of the bands should be present in either of the children. Remember, the other half comes from the mother. That's the principle of identifying which lane belongs to father, right? Now, problem set 2, the first question is linkage and recombination. First of all, do not flip-flop the theta value with the lot score. So tell me out of these two, please. I'm not going to rush over the section. This is important for you. However, we can finish. Rest, we will carry on our review on Wednesday, right? Your review class. So tell me which one is theta and which one is lot score. No, the first questions I told you, the first two I showed you is from Professor Henshaw's slide. There are some practice question in her slide too. There's not another problem set. These are from Professor Henshaw's slide, okay? These ones, right? Remember? Lecture slides also have problem sets. So they are not from another problem set. Okay, just clarifying. Good to ask question. So which one is theta and which one is lot score? Give me value of theta here, please. Very good. Lot score is minus 4.5. And what's theta? Theta is 0.01 given in decimal, which is equal to 1%. Which is equal to 1 centimorgan and 1 million base pair. Very good. Understand that the shorter the distance between two loci, more linked. Larger the distance between two loci on the same or opposite chromosomes, more recombination. Recombination frequency can be used to find the distance between a marker allele and a mutant allele. How do you do recombination? Where does recombination happen? In gamete of one of the parent. How do you count recombination? Given by theta. Don't flip-flop that. Minus 4.5 is not theta. Minus 4.5 is lot score. Be mindful when you read such questions. Then recombination, what is recombination frequency? Theta, number of recombination in a generation or over total number of progeny. A number of recombination in progeny over total number of progeny. And then you find out by recombination the distance between the marker allele and the mutant allele. Here clearly when the lot score is negative. Now how do you find it's linked or non-linked? Definitely minus, there is less or no evidence of linkage. Plus, especially plus 3 and above, strong evidence of linkage, yes. Although between minus 2 and plus 3 is inconclusive, but additive data and positive shows linkage. Minus, absolutely not, unlinked. Does that make sense? Minus cannot be linked. So lot score, anytime they ask you linkage, please first see lot score, not theta. If lot score is positive, especially plus 3 and above, highly linked, significant linkage, right? Then you see theta. Since they are asking linked, you are only going to see lot score. Minus lot score means are the two loci linked or unlinked? Irrespective of theta, please see here. If you see theta, is lower theta more linked? Is lower theta more linked? Yes, so don't get swayed away by theta for linkage. For linkage, you have to see only and only lot score if it's given. Then you go to theta. But here clearly, is it linked? Are these two loci linked? Absolutely not, because this is minus, right? So your answer should be E. Okay, does that make sense? Minus and less than -2, absolutely not. There is no linkage, just know that. With positive, as rising up, you can also add it, which is in the next slide. Yes, lot score here is Zmax also. Lot score is also known as Zmax. Lot score is positive, shows linkage, and it's more towards the lower theta. You got to understand that. You got to very well differentiate theta versus lot score. Are you clear of that? Here you have to add, but you are clearly seeing at locus B, you see more positive lot score, which you can add to. Definitely you should add. The additive effect shows what's the final lot score, but surely the B seem linked. And how many families show linkage here? 1, 3, and 4. 3 out of 5 families. So that's why your answer should be C. Anywhere they ask linkage, go to the lot score, not theta. Yes, if there's no lot score given, then lower theta means more linkage. Higher theta means less linkage. Please know that you have to first know what is this mutation doing. In PKU, autosomal recessive, right? It is an autosomal recessive disease. Please know your autosomal recessive disease, PKU. We have done that. Only those you have done with Henshaw's lecture in this exam. Don't go to fall lectures. You have sickle cell, PKU, autosomal recessive. Achondroplasia, autosomal dominant. Fragile X, X-linked dominant. Anything else? I will tell. DMD, Duchenne's muscular dystrophy. Anyone? Duchenne's Duchenne was X-linked recessive, not autosomal recessive, X-linked recessive. Duchenne was X-linked recessive. Okay, so note that down. Sickle cell, autosomal recessive. PKU, autosomal recessive. Achondroplasia, we did it in these interactive session, autosomal dominant. Fragile X, X-linked dominant. Duchenne's muscular dystrophy, X-linked recessive. Now, what happens in PKU? In PKU, because of the mutation, there is introduction of restriction enzyme target site. That's why you have to first identify which is wild and which is mutant, because remember, this is an autosomal recessive disorder. Both parents should carry the mutant allele. What's the mutant allele here? Capital A or little a? What's the mutant allele for autosomal recessive disorder? Little a. And both parents must carry this little a so that the child has the phenotype. Let's see, they are talking about B, B, and A. I'll call it A, B, and C. Let's do that, right? What a strange name. Anyways, A, B are the nicknames. Why would they do that? Anyways, A, B, and C. So let's find out what would be the fragments for A, B, and C, or pattern for A, B, and C. Again, restriction enzyme have site specific. You can run it on the gel. You can also do southern blotting to identify the sequence. But please be aware that this is autosomal recessive disorder. Since PKU is mutation leads to introduction of restriction enzyme target site. So tell me which is wild, 4 kb or 2 kb? Which one is wild? 4 kb and 2 kb is mutant. So what are mom and dad here? What can you label them? Mom and dad. Mom and dad will be labeled as capital A, little a carriers. Are they phenotypically normal? Are they phenotypically more normal? Yes, only for autosomal recessive disorder. Now, let's look at A. A is normal. So, A will be homozygous for 4 kb or 2 kb? A is normal. Will it be homozygous for 4KB? That's capital A, capital A. But see, first you got to understand that this mutation is introducing a restriction enzyme target site. So the shorter fragment is mutant, not the larger one, right? And since A is normal, homozygous for 4KB, what would be the genotype for A? Genotype for A? Give me the genotype of capital A, capital A. B is a carrier. So B genotype would be B is a carrier. Capital A, little a will show both the bands. And C has PKU. So C will be homozygous for 4KB or 2KB. C will be homozygous for 4KB or 2KB, 2. And what would be its genotype? Little a, little a. So you got to combine your inheritance knowledge with these bands. Please know that allele specific oligonucleotide has clearly here been labeled with, has been radio labeled. Wherever you see the radio label sign, it is positive. Please see, they could also say capital A normal. They could have said capital A little a or little a little a. This is autosomal recessive again, just like PKU, sickle cell is autosomal recessive. Capital A is the wild or mutant. Wild or mutant, capital A. Capital A in sickle cell would be wild. So instead of little a, they have used S. So don't be confused. It's still the same terminology. To the mutant allele, they have given the designation here, capital S. But that is actually a little a, right? Doesn't make sense? Let's clarify, right? So naturally for the same, where will the radio labeled be positive for normal? Capital A for carrier, both probes, and for disease, only mutant probe, right? Do you understand that? Yes. Do you understand the pattern? It's the same, but here the oligonucleotide is radio labeled, and you are seeing the radio labeled positive sign. Please see, these are my slides with annotation. I'll post it on Canvas. I also have notes for you to understand these problem set, right? Though I have one from Dr. Henshaw, you can refer her or you can refer mine's. However, it helps you understand, but give me good grades, right? So let's see this. Again, crime scene, you have to become an investigator, a crime scene investigator in this exam. So this is victim yellow, right? And what are the alleles for the suspect? The red ones. So who cannot be ruled out as a suspect here? Who cannot be ruled out as a suspect? B. So what is your answer? A is excluded, but B cannot be excluded as a suspect. I have done some annotation so it can help you understand better. Again, many students are confused with this paternity or finding out the concept still remains the same, that a child should have one allele from mother and the other half from father, right? First, you got to understand there is no mother lane. I don't know why the forensic scientist forgot, didn't take his vitamins, looks like, but there is no mother's lane. It's only father and children lane. So for father and children lane, first you have to find out the father, because one of the band of father should be in every child, right? So which is the father lane? And that band should be in every child, and those are known as paternal band. So the first lane is father lane. And the bands for father are B and C. So what are the A and D bands coming from? If B and C are from dad, mum. So they are asking the mum bands. So the mum bands would be what? B, A and D. B and C came from father. So mum band is A and D. So principle is still the same. A child should have one band from the father and the other half comes from the mum. Please note down the slides which are not for exam 1. Problem 7, 11, slide, no, please scratch it out. Okay, so that you're not wasting your time. 12, scratch it out. So the mom one does not have to be in every, because mom is not there actually. If you go back, the mom is not there in the in the pattern. They forgot, yeah. It's only the father and these children. So once you found out father, the band which are left, you will assume that it is of mother. Mother is not here. Okay, great. Scratch out 7, 11, please. 12 slide, no, don't do it. 13, don't do it. 14, don't do it. 15. Now, please, problem set 9, know the concept rather than doing this problem, because you're not become your future road is a physician. Let's understand the concept. What is PCR? PCR, each strand can act as a template. Please, doesn't mean that I'm talking about transcription, sense strand, template strand. No, each strand can act as a template and you can amplify the sequence of your interest. How will you do that? You have to start somewhere. You will use primer, right? First of all, each strands can act as a template. Sorry, I'm sorry. But you have to understand why I'm saying that, because DNA sequencing coming in exam 2, only one strand act as a template. Here both strand act as a template. Now tell me, if you put a primer on the top and primer at the bottom, which one will polymerize? Primer is always 5' to 3'. Primer at the top, primer at the bottom. Which one will polymerize? Top one or the bottom one? Because remember, primer is also 5' to 3'. The bottom one. So the bottom one becomes the forward primer and the top one becomes the reverse primer. Principle is forward primer is the same as the 5' end of the amplified sequence. Reverse primer is complementary to 3' end of the amplified sequence. Remember, this is the sequence you want to amplify. That's why you are using a primer. You have to start somewhere. So forward primer is same as the 5' end of the amplified sequence, whereas reverse primer is complementary to 3' end of the amplified sequence. So what is the amplified sequence here? Everything starting from the capital, not the small, which is starting from G here. You have to count how many nucleotides? Only 20. Which is the 5' end? This one. Which is the 3' end? Wherever the capital stops, here. This G is 5', this G is 3', which is this whole sequence given here in capital letters, right? So forward primer, which will be same as the 5' end of the amplified sequence. You have to count up to 20, right? So this one is forward primer, the top one, which I have underlined and highlighted. Whereas reverse primer, remember, forward primer is same as the 5' end of the amplified sequence. But reverse primer, if you go down, is complementary to the 3' end, which is the 3' end here. It's complementary to 3' end of the amplified sequence. Find that out and read from 5' to 3' side. Always you read from 5' to 3'. Please understand the concept, then practicing these questions. We want you to understand that PCR is amplifying sequence of your interest. Each strand can act as a template and you use primer to start from somewhere. The forward primer and reverse primer. Does that clarify the concept rather than doing this problem set? I will give you a chance to ask question. Let me finish this problem set. Please scratch out 16. This is DNA sequencing. Don't do it. Don't do DNA sequencing. This is exam 3. Please scratch it out. Right? I hope I'm clear. I will put a canvas notice. I didn't want to segregate these slides because there are only 3 and 4. and I think it's not worth it, right? I have a lot on my plate. I'm just joking. Just to scratch them out. Yes, I will write down on canvas too. I don't remember. I thought it's slide 7 too. Did I say 7? I will write down on the canvas. Did I say 7? Did I say 7?
Was it problem 7 or what slide was it?
Problem 7. Problem 7. Okay. I think it's 12, 13, 14 if I'm not wrong, and then 16. Don't worry, I will write it on canvas today. Don't do this. Yes, this is DNA sequencing. Don't waste your time. This will not come in exam 1. This will be taught next time by Dr. Chalagundula. Now look at this. Now what is sickle cell? Sickle cell, PKU, do you introduce the restriction enzyme target site? In sickle cell, please understand more the principle first. Then otherwise you will not understand these problem sets. In sickle cell, you lose the restriction enzyme target site. That means the 1.35 kb segment will not be cleaved due to mutation. So if you see an uncleaved fragment, it is not good. If someone is homozygous for uncleaved fragment, is he suffering from sickle cell disease? Yes or no? If someone is homozygous for uncleaved fragment, is that in? Yes. Understand that. If it's a carrier, he should have one uncleaved fragment. If a person is a carrier, which is AS, then probe. First of all, you understood the principle, now probe. Probe 1 is in the direction of a large cleaved or short cleaved. What is it detecting? Large or short? Large or short. So probe 1 will not detect 0.2. What about probe 3? Probe 3 is in the direction of short. So probe 3 should not detect which fragment? Probe 3 should, the large one. Probe 2 is detecting both. You will see both large cleaved and small cleaved in that. So tell me probe 1. Which fragment you will not see? Probe 1. Probe 1, which fragment you should not see? 0.2. Look at this. You are not seeing any 0.2. Probe 2, will you see all? Probe 2, will you see all? And probe 3, you will not see which one? Sorry, probe 3, you will not see which fragment? 1.15. Absolutely wonderful. Does that make sense? The principle still remains same in each one of them. If somebody is homozygous for uncleaved, that is sickle cell disease. Each one of them you will see that, right? Whether the probe is detecting small cleaved, large cleaved, remember, homozygous for uncleaved is sickle cell disease. You will have opportunity to ask me question. I will come back on Wednesday and we have a good time to review. It's an hour review. We can answer question 2. I will also open question and answer session in the next week after you are done with head, neck and neuro and your head is clear, right? So now when you say sickle cell disease, you lose the restriction enzyme target site. So you can't cleave. But in PKU, there is introduction of a restriction enzyme target site. Both are very different, right? And since there is loss of restriction enzyme target site, look at this, an uncleaved fragment, homozygous, actually it should be a thicker band, is sickle cell disease. You can call it little a, or you can call it capital S, capital S. Be familiar with the terms too. Tay-Sachs, hexosaminidases, autosomal recessive, mutant allele, little a, wild, capital A. Both parents have to be carrier. Son is expressing the phenotype. So what's the genotype of this band? What's the genotype of this band? Little a. And since daughter is expressing the homozygous for normal, what is this? What's the genotype of daughter? Capital A, capital A. You should be able to infer the generation and the band and the lane belongs to, this lane belongs to son, this lane belongs to father, this lane belongs to mother, and this lane belongs to daughter. Please don't flip-flop that. Since son had the phenotype, we assume 3kp is mutant and the son is homozygous for 3kb. So that's why daughter became homozygous for 4kb, which got to be wild. So she is normal. You got to bring your inheritance cap here, right? They say thinking cap. I would say inheritance cap. And also, who's phenotypically normal? Who's phenotypically normal in autosomal recessive disorder? Who will be phenotypically normal here? Daughter, that's all. Mom, dad, and daughter. Absolutely wonderful. Great. Looks like a high average in this exam. Everybody's prepared right now. They're more prepared than head and neck neuro, right? So, anyways, now karyotype, there are 3 techniques you should be familiar with. Karyotype, chromosomal painting and fish here. Southern blot, I've already given you. Restriction enzyme followed by gel, followed by southern blot can also be done. PCR followed by gel, followed by southern blot can also be done. Now look at this. What do you think is a problem here? Looking at the karyotype, XXY, absolutely, but rule out. What's Turner's now? Turner's would be to XO ruled out. CML is fusion gene, remember? Fusion gene after translocation, chimeric gene 922, absolutely. Philadelphia chromosome, rule out. Burkitt's lymphoma, wild gene under strong promoter. Wild gene under strong promoter. Wild gene under strong promoter. What is that? 814, starry sky appearance, mandible involvement, jaw involvement. Burkitt's 814. Klinefelter, that's the answer, XXY. And I've brushed up on my Francais. So Cridusha would be loss of 5p, so ruled out. That's why your answer should be, look at this, but you should be able to tell from your karyotype here. Look at my cursor, laser pointer, XXY, right? So you can rule out. Also, clinical finding, XXY may show gynecomastia rather than atretic or streak ovaries. No autosomal anomalies as well as sex chromosome aneuploidies. Yes, less body hair, female-like features in male, XXY, and extra X, which is not required. So understand that. So presentation also you should do, please. But autosome, sex chromosome, and structure. Down syndrome, more common cause, 95% non-disjunction during meiosis. We have to understand mainly maternal meiosis. This is explained on basis of father. That's why you see sperm and then zygote. Meiosis 1, homologous chromosome separate. Meiosis 2, the chromatids separate. How do you find non-disjunction happened in meiosis 1? The 2 copies from a parent are non-identical, one paternal, one maternal. The purple came from the egg or the ovum. That means non-disjunction happened in meiosis 1. Left side. Right side, non-disjunction happened in meiosis 2. The 2 copies from a parent are identical, either paternal or maternal. The purple one came from egg or ovum. Also percentage. Nullosomy, 50%. What about disomy? What's the disomy here? 50%. Monosomy in the zygote, 50%. Trisomy in the zygote, 50%, which is not the same on the other side, right? I'm just telling you how you can come to that. Chromosomal translocation, Robertsonian translocation can be cause of Down syndrome? Absolutely. When there is more than one child with Down syndrome in a family and a lot of miscarriages, absolutely. What does Robertsonian translocation? They are saying it's incorporated, right? Fish can tell you translocation, absolutely. Remember, I asked yesterday, you go back to your primary school. The red and green, when they combine, they give you what color? Red and green will give you yellow. Absolutely, not brown, not purple. Okay, red and green is yellow. So fish can do that. With fish you can see chromosomal translocation. With sky, chromosomal painting, you can see translocation, doubly translocated, triply translocated. So this is definitely a less common cause of Down syndrome, 4%, but 14q21q translocation, as you can see here, which is a balanced translocation because this translocation is between two acrocentric chromosomes where P is very, very small than Q. So even if P is lost, it's okay because it had repetitive sequences. This is still a balanced translocation, but a parent carrying a 14q20q translocation has chance of Down syndrome. Absolutely. Look that in the zygote. Is this a trisomy 21? Is this a trisomy 21? Yes. So yes, a parent with a Robertsonian translocation 14q20 21q, which are between acrocentric chromosome, yes, has a chance of Down syndrome child. And if there are more than one in the family, you do assess that. Also, you should know the difference between karyotyping fish, which one is more advanced, especially fish. But when would you do fish over karyotyping? Similarly, sky, which is chromosomal painting, which is this one. Which is this one on the left? Which is this one? It is a karyotyping. Absolutely. Which syndrome are they showing? Down syndrome, Edwards, Patau, Down syndrome. Absolutely wonderful. There is always a control. What's the control here? Which chromosome? Which chromosome is a control here? 13 in green, right? And here, which chromosome is control here? Green, 13. So what is this? Trisomy 21. So they label these chromosome with a fluorochrome, right? One act as a control so you can know there is no artifact. What is this technique on the left? This technique is fish. Absolutely. Looking at fish, looking at karyotype. This is chromosomal painting. And you see this fusion gene, 1517 fusion or chimeric gene, which is acute promyelocytic leukemia. 15 is PML, which is promyelocytic leukemia gene, and 17 is RAR, retinoic acid receptor gene. 1517 is PML, 15 is PML gene, and 17 is RAR gene. They fuse and they become oncogenic. Right? Is this what technique is this? What technique is this? Sky. And are you seeing, look at this, translocated chromosomes, translocated chromosome, translocated chromosome. That's why this is translocation. Some reciprocal and some unbalanced. Look at 4 and 6. They are reciprocal, right? 4 and 6. Similarly, 9 and 11. But 1 and 14, it's not reciprocal, right? 1 and 14. So, but they are all translocation. Different colors will tell you are they translocated. Balanced is different. This is reciprocal and non-reciprocal. Remember, balanced was 14q, 21q, where though there is a translocation, still the genes lost were insignificant. So it's still a balanced translocation. This is fish, right? And remember, green and red is yellow. So that's why you see an extra yellow here. What is 922 fusion gene, chimeric gene, Philadelphia chromosome? What is that? CMLs, but rule out. Acute promyelocytic leukemia, no, it is 1517, remove. Burkitt's lymphoma, no, it's 814, gone. What about Klinefelter? XXY gone, Turner's, XO gone. So your answer is CML. Absolutely wonderful. Again, is this trisomy? Is it Klinefelter? No. XXY, is it Patau? Is it Patau? No. 13 trisomy, is it Turner's? No. XO, is it down? 21, no. 21 trisomy, is it Edwards? 18, and what's the control here? 13. Is this fluorescent in situ hybridization? Is this fluorescent in situ? Is it showing you fusion gene? Is it showing you fusion gene here? Yes or no? No. This is showing you trisomy. Fusion means red and green should be fused to give you yellow. This is not a fusion gene. This is showing you trisomy. The 18 is in, there are 3 trisomy. This is not showing you fusion gene. So you should be very clear, no. No means no, even in life, right? Okay, wonderful. Take that life lesson. Twins, they are more similar, so they are twins. Remember monozygotic and dizygotic twin? Definitely do the identifying disease with the help of mono and dizygotic twins. Remember, if the disease is near 100 for monozygotic and near 50 for dizygotic, does it have a highest genetic component? Remember that? Yes, very good. Now look at this again. You remember that a child has one allele from the dad and other half from the mum. So that the blue are from dad and red are from the mum. So that is why none of the children can be excluded. I have color coded it so that you can quickly understand it. I will post this on Canvas. So can any child be excluded? Each one of them have each one of them have, did I say the opposite? I said the blue is mother. Oh, the blue is father and red is mother, right? Okay, great. So can any child be excluded here as not being the biological father and mother for that? No, none of the children, because and our principle is still the same. One band will come from the dad and the other half will come from the mom. Here you have to see crime scene. Again, you have to be an investigator on the exam, right? So here, this is the victim band and this is the suspect band. So who cannot be ruled out this time? A or B? Who cannot be ruled out at this time? A or B as the suspect? A, right? Yes, because these are the AA band, right? On the crime scene. So the A cannot be ruled out. B is excluded, but A cannot be excluded, right? Do you see that? This one I told you, please neglect which lanes. Again, if you have to find out who's the suspect, you will not see the crime victim lane. 1, you will not see. 3, you will not see. 4, 6, 9, and 12. See the other lanes and find out who's the suspect. 1, 3, 4, 6, 9, 12. Yes, you will not see. That is crime and victim. You will see the other one, right? Does that make sense? One allele comes from each parent, the other half, one from father, the other half from mother, or one from mother, the other half from father. So the father cannot be excluded. The father is the biological parent. Restriction enzyme. Restriction enzyme identifies palindromic sequence. What are palindromic sequence? You can read them same on either side. How do you find out them? Where would you start? Right from the center. Did I tell you that? Start from the center and move out. Which one is complementary here? Start from the center and keep moving out. Does that make sense? And so this is the right answer. You will start from the center. Sorry, give me a second. You should start from the center and keep moving out. And that is the sequence which is the right answer. Because remember, what does restriction enzyme identify? Palindromic sequence. Here again, go from the center, move out, you will get the answer. Go from the center, move out, you will get the answer. Does that make sense? Right? Is it easy? It's easy peasy, okay? We did that in the class too. Great. We start from the center and we keep moving out. That is how you have to find out the palindromic sequence. We did it in the class too. Good luck. If you have any question, you can ask me. Otherwise, you can relax for head, neck, and neuro. Clear your head. Good luck, everyone. Great. Great. Anyone has any question though? You're welcome. You're welcome. No worries. Take care. Take care. Next week. Everybody's good? Okay, great. Yes, Tamara, tell me.
Good morning, Dr. Bog. If I can just ask regarding the one with missing the mother, can we go back to that one specifically?
Sure. Yes, please, please. Okay, we will do that. So when you're doing where the mother is missing, where the scientist didn't take the vitamins, right?
Yes.
Okay, so which was, just a second, was it this one, right?
I believe so.
Results. No, not this one. Sorry, not this one. No. I don't think so. That's that one. Do you remember the number? Here, this one. I think it's this one.
Yeah, this one, exactly.
Right. So in this, remember that you have to first find out father lane. Your first job. Oh my God. No worries, I'll go back. Your first job is to find out the father's lane, right? And also, you know the principle that one band will come from the father, mother is not in those, in that pattern. Mother has been forgotten. You will assume then whatever didn't come from father came from mother, right? Maternal, paternal. Is that clear with you first? Right?
Yes, definitely.
Yes. So now you have to definitely first identify the father's lane. Otherwise, you cannot assume the other is maternal, right? So that's what you will do. I'll show you how do you do this question. Oh my God. All right, let's scrape off this everything. So that is why you try to see which lane has one allele at least in the other child. And you see that these are this lane 1 is the only lane which has one allele in each child. The other allele, that's why if you can go and practice, you can also assume 2 is a father, 3 is a father, 4 is a father, 5 is the father, but you will not get the answer. You get my point how you have to do this? You first have to identify the father lane. Only lane 1 has the allele, a band which is in each child. That's why lane 1 is father. There's no mother lane. They're all children, 2, 3, 4, 5. So you will assume that the remaining came from mother. Does that help? Sorry?
So we assume that A and D are the mother because of the fact that they are not present in every other child.
No. We are assuming that A and D are maternal because that band is present in each child but did not come from father.
Oh, it did not come from the one lane. I see.
Right?
Wonderful. Thank you so much for explaining that. Sorry.
No worries. No, practice that. You will go home and practice. Assume lane 2 and you will not get the answer. You can do that. Assume that lane 2 is father and you will not be able to justify that. So you got to practice it. So no worries.
Thank you so much. Have a great weekend.
Okay, great. Good luck.